All right, everyone, welcome back to the land of Chem. I'm your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again.
All right, everyone, welcome back. Now, today we will continue examining the function of the bent pyramid's primary reaction chamber with the discussion of alternative chemical products, an introduction to new mechanisms of operation, and a journey inside the structure so you can see the internal components of this immense machine for yourself. Ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's intro. So without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. Now, to begin, in episode 167, I explained the basic function of the bent pyramid's primary reaction chamber, which involves a reaction between carbon dioxide and aqueous ammonia under ambient temperature and pressure conditions that produces a solid compound known as ammonium bicarbonate. A very simple reaction that involves the percolation of carbon dioxide gas up through the aqueous ammonia solution, resulting in the formation and precipitation of solid ammonium bicarbonate. However, given the configuration and physics-based engineering of this reaction chamber, the system is designed to produce higher temperature and pressures that would result in an alternative product. Remember from back in episode 157 regarding the reaction chambers of the red pyramid. I presented a series of calculations demonstrating the capability of these chambers to create high temperature and pressure as hydraulic mechanisms of operation produced an adiabatic compression reaction, generating conditions within the chamber of over 500 degrees Celsius and 40 atmospheres of pressure. And the primary reaction chamber of the bent pyramid, located at ground level within the core of the structure, was originally configured with the same physics-based engineering. This tiered upper vault that you can see on the left, that was designed to reduce volume, thus increasing temperature and pressure, which would allow a more complex chemical reaction to occur, which is exactly what we do today, where the same reactants, ammonia and carbon dioxide, are introduced into the reactor under higher temperature and pressure conditions, resulting in the formation of a slightly different product. This time, instead of ammonium bicarbonate, we have ammonium carbamate, an intermediary product that is later dehydrated to yield urea. This exact same reaction can also be produced by introducing the carbon dioxide in a dissolved aqueous solution instead of as a gas, which would increase the volume of water in the chamber, a function that will be useful as you will see in just a moment. And just like we do today, the red and bent pyramids of Dashur operate in conjunction as a pair, a series of chemical manufacturing facilities whose functions are interconnected, with the main product and byproduct of the red pyramid, aqueous ammonia, and the carbon dioxide byproduct being utilized within the bent pyramid for the synthesis of urea, according to the following reaction. Again, with the intermediary product, ammonium carbamate, dehydrated to yield urea, with the ammonium carbamate urea being extracted from the system as an aqueous solution. This will be coming up again when we reach the final stage of the reaction sequence. And in Members Only episode 11, I explained how the bent pyramid may have also been producing a completely different chemical using the aqueous ammonia product of the red pyramid in a series of chemical reactions that involve the conversion of ammonia gas and oxygen into nitrogen oxide and water, which is then further oxidized into nitrogen dioxide and then dissolved into water to produce nitric acid in a high temperature catalyzed chemical reaction that also fits the configuration of the chambers within the bent pyramid, where the ammonia gas is introduced into the primary reaction chamber over a heated catalyst material to generate nitrogen oxide, the first step in creating nitric acid, the second half of the chemical equation required to generate aqua regia, the hydrochloric acid, which we already have as created within the central pyramid of Giza. Check out episode 139. And the brilliant engineering of the bent pyramid is capable of generating both of these very different chemical reactions and products, with the upper primary reaction chamber and the lower chamber system integrated into the most complex reaction system within the Egyptian pyramids. Now, before we proceed, let's take a journey inside of the bent pyramid so you can see these chambers and the evidence of the chemical reactions up close for yourself. All right, everyone, just a quick announcement. The first book in the Land of Chem series is now back in stock. This gorgeous Egyptian Blue second edition is the exact same text as the first print, but now featuring the new blue color design. Also, a brand new merch shop is up and running, featuring all of your favorite logos, tons of new color options, and my personal favorite, stickers. So whether you are sticking these to the bottom of your skateboard or plastering the walls of your office bathroom stalls, go grab some now and put them everywhere you can find a spot. All available at thelandofchem.com. Thank you all so much for the support. Now, back to the video. All right. Now we're back here inside the lowest separation chamber of the bent pyramid. And this time, I promise, I didn't do it on the last visit because I was stuck behind a group of tourists and I didn't want to be filming their asses on the way up the northern shaft. But I'm going to take you with me as I ascend back to the light today to show you several very interesting details about this northern shaft. And I won't spoil the surprise, but stay tuned to the end of the video and I will take you with me. So now, in last week's Sunday site visit, we explored the lower separation chamber system, which I am now climbing up into the upper part of this dual chamber system. And the chimney area here that is now blocked off with all this rubble. And I showed in the previous episode the shaft that goes down at the bottom of the pit, which may be connected possibly into the satellite pyramid. Also possible that that pit connects into the pit down here at the bottom of the northern shaft. All of which are still unexcavated. So now we're going to ascend the ladder and I'll take you on a journey through the connecting passage and we'll explore the primary reaction chamber. Pretty badass day so far out here in Dashur. All right, let's go. All right. Reach the top of the staircase here in the upper vault. And I'm standing here near the down flight here so you can get some perspective. Here's one of the holes. And the opening into the connecting passage. And I can already tell you, just standing here on the threshold of this passage, I can feel the airflow rushing out from inside of this passage, and let me tell you, it feels pretty damn good. So now, we'll go nice and slow through here.
so you can get a sense of what it's like to crawl through this passage. It's maybe 3.5 feet high. So now, see if you can hear it. My stomach is growling because I'm in the depths of my Thursday fast today. But I'm hoping the GoPro microphone can pick up the sound of the wind. And I will say, it's coming in this direction. And it's just rushing past me right now. We're about halfway through the tunnel. You can see the western shaft over here and the upper vault of the lower separation chamber. I'm sitting on a part of the passage that my colleagues and I at the Osireion project call the step, because there's literally a nice little flat plateau here, and this is a steep incline within the passage. It certainly appears okay, so I moved down a few feet. And the wind flow or airflow has almost stopped in this section. So now let me turn back around. This is where I was sitting before. Pull it back up here. Oh, there's a bat. I don't know if you can see that, but hanging out up there. And the airflow has kind of stopped now. So as I mentioned before, I'm working in conjunction with the team at Osireion on a project here inside the bent pyramid. I won't reveal the purpose of that yet. It's not my place to do so, but our team may have discovered something pretty interesting inside of the structure. And I'm just pausing every few feet to see if I can feel that airflow moving through here again. Alright, so now the western shaft system. And this was not blocked off in 2010. One of the guys in the Osireion project climbed over this little hole and up the western shaft. And so these holes here, I don't think are original part of the structure. And I'll show you why. Because this section of the wall has been excavated back. This entire piece here, this is the original level of the wall. This entire part has been moved back. Later modifications to the structure, which I think include these holes. I don't think these are original. And you can see here, the original part of the wall that is flat here has been chiseled back, and all of this stone has been removed back in this portion. So I do not think that these holes are an original part of the structure. And this whole section here was all chiseled back from, see the flat wall, original, chiseled out. And you can see here too, this is where the original part of the wall would have come up here, and this whole section was chiseled back. And now, directly beneath my feet is another unexcavated pit. Let's get this down here. Again, the connections to the satellite pyramid on the south are yet to be revealed, but there are numerous indications that there may be connections between these shaft systems, the valves, and the southern satellite press mechanism, hydraulic press mechanism. And I'm just standing here. There is some airflow coming in through this area, but it's certainly not significant enough to generate the current that we see within this connecting passage. Because again, how is this airflow whipping down here, whipping around the corner, and getting stronger inside of this passage? The airflow is coming from in here. Here we are, taking a look at one of these stone valves. And the housings. Hole right there. Square one. This one's definitely modern here. You can see the chisel marks where this one's been. And looking up into the housing here. And now we'll proceed into the primary chamber. And my main objective for today is to look in this little hole here to see if I can get some footage of the quartzite block that was discovered in here. Hang on one sec. And if I was certain that I could get back out, I would climb down in there to take a look. Hello. All right, and I'm just investigating this portion of the western shaft system, and I happen to notice that there is remains of some coating here. This piece here. There's a little piece here. There's a big patch here of coating. More here. And here. A big patch here. And this does not appear to be mortar. The mortar that we have seen has a very rough consistency. This is very hard and very smooth. See this piece coating here, here. There's more here. Here. And this material feels very different than the stone itself. It's very smooth. See another piece of it here. You can see the depth of the layer. And this looks very similar to what we saw in the final pyramid of Giza. Those guys are from Spain. I just heard him scream, "Joder," which means fuck. All right, now. And I've discussed before that the platform here is not an original part of the structure. And just look at the significant erosion on the walls inside of here. And we'll be coming back to investigate this chamber later. But I just wanted to point out this erosion here. You will also see some very similar erosion in the lower section of the northern shaft. And I just wanted to point out that the logs inside of this chamber that were dated to the dynastic period are not an original part of this chamber. These logs are a part of the framework that was used to excavate. They're part of the framework that was used to erect the platform that I am currently standing on. You could pop those logs out and it wouldn't make one single bit of difference in terms of the structural integrity of this main chamber. You can see there that these beams are mortared into place. And part of this platform sat on top of the beams. And even conventional archaeologists agree that this platform was not an original part of this structure. And the upper vault here was originally a pristine tiered vault. I'm just going to show you the rounded erosion on these walls. And from lower down here, you can get a better perspective. Of the curvature of that erosion. You can see how rounded out this is. Eroded all into that upper vault. This entire chamber was originally a pristine tiered vault that has been eroded away. So now, we're gonna head back toward the entrance so I can show you some very unusual details about the northern shaft system. All right, now, as promised, we will begin the ascent back to the surface, to the light. And you can already see down here, look at how curved this is and eroded, this lower section. This passageway is. Look at that. Completely rounded out. And you will see as we ascend here, look at how rounded and smooth this is. With no indications of chisel marks or tools that did this. It is eroded. And another section here. So you can see the erosion on the interior. And looking back down. Look at this. This was once originally a square shaft, similar to what we see up there at the top. This entire lower section has been eroded away. All this erosion here. Section displays that significant erosion. And looking back down, that's on both sides. Look at how smooth this is. One other thing. That I noticed for the first time when I was coming down through here. Up at the portion of the shaft that still has the squared masonry. Still going through a section that is extremely deteriorated. Look how smooth this is. That is erosion. Look at this. Look at how smooth and eroded that is. The question you should be asking yourself is what caused the erosion on the inside of this structure. And here we are. Back to the portion that is still squared off. This is about halfway from the bottom up to the top. And I just happened to notice this on my way down here, and I'm not going to make any suggestions as to what caused it because it's extremely difficult to tell. But I don't know if you can see that there's some scrape lines leading up in this direction. Some over here. Specifically down here. Scrapes. Unusual. Looks like a huge gouge running all the way up the shaft. Well, is this damage from hauling something out of here? I just happened to notice this when I was coming down in here. I thought it was pretty unusual. Or was there something sliding down this shaft at one point? There's more. I will say that the scrapes are at the same angle of the slope shaft itself. Same slope as the shaft itself. And looking back down. And the finish line.
All right, everyone, I hope you're enjoying the video, and please remember to subscribe if you're interested in the function of the Egyptian pyramids and other ancient structures from around the world. If you want to help support the channel and get access to exclusive research content, check out the members-only channel, now up to 25 absolute banger videos. We also have 3 other channels: Egyptian Trash Cats, the best channel on YouTube, Let's Go with Lex and G, and my wife Alexa's channel, Ancient Odysseys. And if you're interested in joining for a tour in Egypt, please send me an email to contact@thelandofchem.com, subject line 2025 Egypt Tour. Links to everything in the video description below. Ladies and gentlemen, as always, thank you all so much for the support. Now, back to the video. All right, now that you've seen the internal reaction chambers, let's resume with the operation as presented in episode 167. That begins by filling the primary reaction chamber with the aqueous ammonia solution, and then introducing the carbon dioxide gas, which will percolate up through the aqueous ammonia solution. As I mentioned before, the carbon dioxide could also be introduced as a dissolved aqueous solution with the same chemical reaction between the carbon dioxide and ammonia that produces solid ammonium bicarbonate precipitate. Now, by activating additional components within the bent pyramid, the temperature and pressure within this chamber can be increased, shifting the reaction toward the ammonium carbamate intermediary product to create urea. Now, for the following animation, I will be using this exceptional diagram showing the upper reaction chamber system from the west to east axis and the lower separation chambers from the north to south axis. Now, recall from episode 161 that the bent pyramid also has an external reservoir, with the water being introduced through the reservoir inlet pump housing, exactly like what we have at the red pyramid. That external reservoir is now included here on the diagram, and the water will flow into the chamber system through the inlet shaft that is located in the upper separation chamber. There are actually 2 shafts located in this lower chamber system: the inlet here and the extraction shaft here that will be coming up at the end of the series. The water will begin to fill the lower chambers and will also rise into the northern pump shaft. More water is introduced until the water level has reached its maximum, establishing an equilibrium between the pressure inside of the chamber and the weight of the water column in the northern pump shaft. The pump mechanism is then activated, forcing the water up into the system through the connecting passage, filling the space in between the 2 valves in the western shaft. Now recall that when we started the reaction sequence in the primary chamber, the first valve is closed, so that chamber can be filled independently of the pump and pressure system activation sequence. Next, water is introduced into the western pump shaft through the inlet located at the bottom of the western shaft, the exact same configuration as the water inlet at the bottom of the northern pump shaft in the red pyramid. The physics-based engineering and these mechanisms of operation remain consistent across the board within all of the Egyptian pyramids, providing a comprehensive explanation for these systems that address each component under the same umbrella as being applicable for the chemical manufacturing sequence. This western shaft, coming in from way up here on the side of the pyramid, is completely useless for a pharaonic burial and utterly superfluous for any other purpose except for the function that I am about to describe. The water level will continue to rise in the shaft against the closed valve here until it has reached the maximum fill level. The pump mechanism within the western shaft is then activated, and I'll be coming back to this western pump mechanism later, as we have archaeological evidence of its existence that was discovered inside of this shaft. Both valves are then opened, and the water is compressed into the primary reaction chamber. This mechanism serves two functions. First, to increase the temperature and pressure within the chamber, and second, to introduce more water into the reactor. This process dissolves the precipitated solid ammonium carbamate product and allows it to be transferred into the lower separation chamber system as an aqueous solution. So now let's run the system again without narration so you can see the first reaction sequence within the bent pyramid in full operation. Let's go. All right, everyone, that is it for today's video. This was episode 168, The Function of the Bent Pyramid, Part 2. I really hope you enjoyed today's video, and in the next episode in this series, an absolutely massive on-site research investigation to finally reveal the function of one of the most critical components of the Giza Plateau industrial complex system. This is an episode you do not want to miss, so if you haven't already, please subscribe to the Land of Chem here on YouTube, and remember to click that little notification bell so you don't miss out on the new episodes that premiere twice per week. Please like, comment, share, and stay tuned. If you want to help support the channel and get access to exclusive research content, check out the Land of Chem members only channel and thelandofchem.com if you want to pick up a copy of the book or grab some merch. Links in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our 3 other channels: Ancient Odysseys, Let's Go with Lex and G, and the best channel on YouTube, Egyptian Trash Cats. All you cat lovers out there, ladies and gentlemen, as always, thank you all so much for the support. I think that's it for today's episode. I will see you next time. Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.